What's up, hackers? Welcome to Saturday Hacker Day. My name is Taggart, and today we are going to tackle something I've been really wanting to talk about for a long time. Before we get there, though, we have a lot of news to cover this week. 4 stories, which I think is a record for the This Week in Cyber segment, but there's enough that it's worth talking about. We're going to dive into it. So first, and perhaps most obviously, we have to talk a little bit about CVE 2022-26809, because everybody is. But what they're talking about and how they're talking about it could use a little detail. So what are we talking about here? This is a vulnerability in a Windows component known as MSRPC. This is not as was originally described, and I'm pretty sure still in the Microsoft MSRC advisory, listed as an issue with Server Message Blocker SMB, which if you're in this realm, you know is usually offered on port 445 and is a big no-no to put out on the internet. But this isn't actually an issue with SMB, which is the file sharing service most of us are familiar with in a Windows environment. Instead, it is an issue with the remote procedure call protocol that Windows uses sometimes over SMB, but not all of the time. The clearest explanation that I have found of this issue is from Jake Williams, also known as Malware Jake on Twitter's SANS presentation, which is actually available, the slides for which are available on GitHub. So I've just posted those in the chat. And let's talk for a second about what RPC is and why it's a little bit hard to get a handle on. What RPC does is allow applications to communicate across a network without necessarily knowing what the underlying protocol is. It's like a meta protocol. And so the first thing that happens is that there is a mapper of services, which is advertised usually on port 135. And if you've ever noticed when you do a port enumeration of a Windows machine, there are kind of three that almost always are there: 135, 139, and 445, right? And you'll sometimes even see 135 listed and 139 listed as RPC or CIFS. And then the other thing you may have noticed if you're in a Windows environment is that very often there will be bananas numbers of really high port numbers open on systems. And that always freaks people out. In fact, it freaks people out so much that we made it a WTF bin to indicate that this is normal behavior. But like, why are these high TCP ports open all the time? What's going on? This is part of RPC, and what happens is that the RPC service mapper on port 135 is actually creating ad hoc TCP connections on those high ports. Now, in older versions of Windows, they were slightly lower ports, but they were still arbitrary. And then Windows, I think 8 plus, uses like in the 50,000 range. But that's what that is. So the issue is actually not in SMB, it's in RPC. Why does that matter for this conversation? The original guidance from Microsoft was to just turn SMB off at the network edge, which you weren't supposed to have open at all. ZM00, no, it wasn't. And this is the problem. It wasn't just port 445. The original guidance from Microsoft said, oh, just, disable 445 at the perimeter and you should be good. That is not correct. Because the issue, as it appears in RPC, not in SMB, could be anywhere, not just port 445. What's more, Marcus Hutchins, also known as Malware Tech on Twitter, and of WannaCry fame, he stopped it. He didn't do it. He reversed the patch for the vulnerability and discovered that the issue really exists not just in the RPC server, but in the RPC client. Now, we have not seen a proof of concept for this vulnerability yet, as far as I know. That doesn't mean that there isn't one. It's just that there isn't one that has been publicly released. But it also means that the only true remediation for this is the patch itself. There is no kind of security perimeter remediation, because if an attacker has the ability to get on an endpoint and can exploit this vulnerability that is present both in the server and the client, okay, we may have greater issues to worry about. So there is a patch available for this. It was released as part of the latest Patch Tuesday updates. Make sure that you get this installed wherever you possibly can if you're responsible for this. Okay, next up, This one's crazy. Okay, so GitHub last night reported that OAuth tokens were breached, affecting dozens of organizations. So, and in particular, the OAuth tokens that were stolen were issued to Heroku and Travis CI. What we're talking about here is if you've ever integrated a third-party application with your GitHub account, right, and you have to authorize it to do that, the way that that authorization works is with an OAuth token. And these tokens are tied into the accounts of those services. Heroku and Travis are obviously massive, massive organizations that have connections to multiple GitHub accounts. And what GitHub has now reported is that there's evidence that data has been downloaded from dozens of organizations, according to the Hacker News, including, keeping me up forever, NPM, the Node Package Manager. Now, we don't have any evidence yet of further compromise of those Git repositories, but it's a really, really scary supply chain kind of attack where using a trusted relationship between a service provider and your source code repository, all of a sudden, despite your best efforts in trying to do everything right, your source code has been compromised because of this relationship. It is very difficult to stay on top of these kinds of security issues. Now, obviously, these tokens are revoked and they'll have to be regenerated. GitHub is also notifying any affected parties that they've detected. Nevertheless, I do think it's a good case study in really kind of subtle and difficult to defend against security issues as we rely on more and more third-party services. That sentence really doesn't even mean anything anymore as we rely on more and more third-party services. That would have meant something in like 2010. But the truth is that third-party services are everything now, right? We are a distributed computing environment no matter who we are. And the ability of an attacker to compromise one chain of it that you rely on and cannot ignore and cannot do without really, really makes the defense situation challenging. All right, a little bit more of a classic issue here from Cisco. And I decided to report on this one given our case, our study material for today. But this vulnerability, CVE 2022-20695, also is notable in that it scored a perfect 10 on its CVSS score. That's how bad it is. The issue exists in Cisco's wireless LAN controller software. So Cisco does produce wireless hardware and controllers to control wireless access points. They even have a virtual wireless LAN controller that you can install on Linux servers and things like that if you don't want to buy their gear, but want to buy their software. Well, it turns out that there is a mistake in the way that their encryption algorithm is verifying passwords. And so an attacker could actually, in specific configurations, bypass authentication to the wireless controller. So if you have Cisco gear, make sure that you apply any patches from Cisco according to their guidance. But yeah, these things still happen. And one of the things that caught my interest about this was the idea that they could make a mistake in their encryption algorithm like this. It's one of those things where it's like, wait, I mean, we know how to do this the right way. Why wasn't that done? There may have been a good reason, but it's just kind of a head scratcher on that one. All right. And then lastly, let's end with some good news. The Zloader botnet has been brought down through a partnership between ESET and Microsoft. Essentially, what they've done is seize control of 65 domains that were being used to operate the botnet. So pretty exciting. Now, Zloader and TrickBot kind of share some DNA. They were both banking Trojans back in the day, and they've evolved to become malware as a service. Zloader isn't used as much anymore. There were kind of like two main operators left, and the customers and operators have moved on to other kinds of malware like BazarLoader. Nevertheless, I think it's a huge win for the good guys whenever a botnet, especially this many domains, can be taken down. So good news all around for that one, and congratulations to Microsoft and ESET on a successful anti-malware campaign. All right. A couple days ago, I was having a conversation with somebody about network segmentation, and it occurred to me that there's this massive gap between what a lot of security folks have had experience with on the networking side of things and what I have had experience with on the networking side of things, just because my career has been kind of weird in that I've had to create full networks for small to medium sized businesses multiple times. And when I say create full networks, I mean running the cables, configuring the switches, doing the wireless, handling the security from soup to nuts, up to and including working with the contractors building new buildings to target how we're going to set up the wireless drops or the wire drops, and how we're going to run the conduit for the cable, where the server closet's going to go, everything. So because of that, I've had this experience, and now I work in security, and I can think about network engineering in a little bit of a different way than sometimes security folks do. And what I want to do today is build a network with all of you. We're going to build it from scratch together, and we're going to think about why sometimes security isn't the first thing on the minds of network engineers, and what the challenges of securing even a smallish network can be if it's anything like complicated, or anything like not just a couple of machines to the internet, right? Like a home network. So we're going to do that using a tool called Cisco Packet Tracer. And if you haven't used Packet Tracer before, it's like Civ or The Sims for IT people. It is unbelievable. And what's even more unbelievable is that the tool is free. You can go download Packet Tracer from a number of different places, but I'm going to give you this link right here that allows you to go find where to download it. Now, you should sign up for an account. Cisco offers two different kinds of accounts that you can sign up for that will allow you to authenticate into Packet Tracer and do your work. So go do that. But once you have that account set up, Packet Tracer is free to use. So let's go build a network together. And I'm going to be taking as much input from you as possible. I'm a little bit rusty with this, so bear with me if I have to like relearn stuff. But the truth is that network engineering involves a lot of Googling anyway because of these interfaces. And yes, it is going to be a Cisco focused kind of thing, because they don't have, the Cisco Packet Tracer doesn't have, like Palo Alto devices in there. Nevertheless, the concepts I think are going to be really, really useful. So let's get started. Okay. Here we are in Packet Tracer. There's not a whole lot going on just yet, but I am thankful that Packet Tracer allowed me to make the font bigger so that we can actually see it going on. So Packet Tracer is kind of a wild thing. What you can simulate is frankly astounding. What do I mean? Well, here we are in our logical network view. We don't have anything just yet, but if we go over to here, we can kind of see that there's an environment listed, and we can set up parameters, no kidding, for things like, we can set up parameters for things like electricity, how much heat there is, what the atmospheric conditions are? What? Why? How much electromagnetic radiation we're dealing with if we want to test our wireless connections? How much heat are we getting? Are we on a boat? Do we have motion that we need to worry about? Is there a whole lot of sound for some reason? What is the temperature that we're dealing with? Is there water? Look at all of this stuff that we can do. Right? We can basically create our whole world here. Yep. Gotta test packet loss during a solar flare. That has happened to me for sure. That's not it's funny, but that has happened. I remember one time I started getting dozens of calls from teachers saying like, why is the wireless down? And I could not find a technical reason why it would have been down. Everything was working, everything was set up, but sure enough, I was getting massive packet loss during at this time. And so I went to like spaceweather.com, right, and found out that we were in the middle of an X-class solar flare. I was like, oh, okay. Yeah, so your wireless doesn't work because the sun burped? Happens. All right, so we have kind of two views in Packet Tracer. We have the logical view of our network and the physical view of our network. And I actually want to start in the physical view because if we're talking about building a network, right? There is a physical component to it, and the physical component is part of where network engineers live, not necessarily where security people live. And it does change the way you think about the network and what kinds of things you need to worry about. So I'm going to go over to the physical view here. I've added this image from Google Maps of Los Angeles just to make it look a little bit cooler. You can do that. You can set whatever background image you want. Set the background image, right? And then I've created just this site, this building site for Taggart Tech HQ. And I have an MDF, the main distribution frame, which is usually in a building where the internet comes in from the street. And then we have an IDF here. Zoom that in, the business IDF, which is going to be like the business office. And we can set up other server closets as we want. But we'll start here. So I want to actually not start with the networking equipment. I want to start with endpoints and think about how we network them together, because that's going to make it clear kind of how we have to build our network architecture, right? So here we have the break room. Let's label some rooms. You know, why not? This office doesn't exist, but if it did, I know for sure that the Taggart Tech headquarters would have a bunch of classrooms in it. So we'll make some classrooms. Move this over here. Classroom A, classroom B. All right. I like it. It is insane to me that this is the MDF. It's a massive space, but whatever. You can, I think, already tell how crazy you can get with this stuff. And let's see. Husky's office. Need a restroom. And this is, in fact, going to be the business office. Haven't made it to the corner office yet. No, but your office is bigger than mine. This is by the... I didn't make this floor plan, by the way. Yeah, you have a window. Here, hold on a second. Let me add that. Yeah. It's the business office. Do you have a window? Sure you do. Let's go to miscellaneous. Sorry. Network devices. I thought it was in miscellaneous. No. And devices, home. Okay, there are doors. I thought there was a window in here. But yes, you have a window. And this was really why I made your office, Husky. We know that you're going to need a coffee maker. And of course, it's an IoT device. So that's our first network device actually on the board, is Husky's espresso machine. Okay. But let's go ahead and add some devices. So we'll make a couple of PCs. So we'll put a classroom computer in each of these classrooms. We'll call them class PC A. Cool. and class PC B. Okay. Again, all we've done is create endpoints here. We haven't done anything else. Let's obviously give the business office a couple of PCs. Oh, we're not ready for that. Biz PC 1. Biz PC 2. Now, so far we're talking about a wholly wired environment, right? But obviously we may want to have a wireless environment as well. And so let's think about maybe some wireless access points. Let's give Husky a PC and a server, because we know he's going to be doing a thing. And I'm also going to have a PC and a server. Okay, love it. And got this other office that we're not using yet, but that's fine. I think we're proving the point here for the moment. And then, as I said, we'll do some wireless infrastructure too. So we'll do network devices, wireless, and hey, look, there's the wireless LAN controller. All right. Perfect. We'll take this AC access point. Oh my God. It has so much coverage. Look at that. WAP 1. I'm going to toggle off the network coverage if I can. Yeah, there we go. Oh, I see. If I hover over it, it'll... Interesting. Now, this is actually kind of cool. The truth is that in real situations, we would kind of want to do a backbone of access points here. And we want to fill in the dead spots. So this is actually kind of cool. That's perfect. Coverage like that. Yeah. Okay. WAP 2. And the truth is that radio signals do get knocked down by stuff, especially steel and concrete. So depending on where we are, architecturally speaking, we might need a couple of access points in other places. And I know for sure we're going to need access points in the classrooms. Ask me how I know. Awesome. All right. And let's toss a couple of laptops in the classrooms as well, just because, right? Fun. Okay. Now, all of these things are just not connected to anything, right? So we have to start building out our connections. Let's begin with our internet connection, right? So let's go to the MDF and let's zoom in on our rack. Right now, we don't have anything on here. We just have power distribution device. So it's time to actually add something. And we're going to add router. I should have a cable modem in here. WAN emulation. There it is. So there's my cable modem, and I'm gonna boop, pop that right in here. I can't put it on the rack for whatever reason because it's not rack mounted, but I do have a cable modem, which is kind of cool. And if I click on it and zoom in, look, I have this coaxial connection and I have a fast Ethernet connection, and it's on. So I don't have uplink to the internet just yet. We have to simulate that another way. Yeah, let's go on the floor. Hey, the Guar. Glad to see you, bud. I mean, sometimes they do. This isn't like an enterprise modem, though, which is kind of interesting. And I don't have a fiber option either, which is kind of interesting. But that's fine. And then on our rack, the first thing we're going to do is have a router. And we'll do the newest router that we have, which is 4331. Yeah, let's go. Put that right up there. Now, actually, ironically, if this were on the floor, I wouldn't put it here. I would have to like knock it down here because I wouldn't have to run the cable that high because that would be dumb. But whatever. So here's our router. And if we click on it, we get some more details. This is... you can see how you can lose days to this, right? Because it's simulating all of this stuff, right? Every single one of these ports is something that I can click on and work with. And I can even click the power button to power it on and power it off. In fact, I need to power it off to make changes. But I do have, let's see. I don't need to add any additional modules to our router, but I do have gigabit connections. So you can see here, let's power it back on and hover over this. It'll have to boot up, but you can see that I've got, it's kind of hard to read if you're not used to reading Cisco stuff. In reality, I leave 1U for putting the backup modem system on top of the routers. Absolutely. That's right. I don't think I've met a real world, not data center, but like a real world MDF or IDF, where some component wasn't a load bearing component for something else. Whether it's like a wireless controller that just kind of sits. Who was it? Not Aruba. It's gonna drive me crazy. Not Aruba, another wireless manufacturer. They would ship you the wireless controller, and it was like this big. And so they had these massive brackets. Ruckus, thank you. Yeah, Ruckus would ship you these massive brackets for their controller to connect to your cage. It looked very goofy. Okay, so at this point we have a router so we can connect to the internet, but then what do we do after that? After that comes my personal favorite part of the networking environment, which is the switches. So we're going to add a 3650. Now, there are way newer switches than this now, but this is what we have in Packet Tracer. And it's fine. It's a layer 3 aware switch, so we'll do what we can with it. So let's move this right on to our rack. And what do we have in here? We have 24 ports, 24 fast Ethernet ports, and we should also have, what other modules can we toss in? I don't think we have, yeah, that's a 1000 base T. Do I have fiber on here? I don't. But if I wanted to do fiber, they would go in one of these ports over here. with the SFP modules. But my favorite part about this is in order to turn this switch on, I literally have to move the power supplies into position. And we'll do a redundant power supply. And these are the fans. Okay, with that, our switch should be operational. Let's look at the CLI. No. So I actually have a full CLI for the switch inside of each one of these. That's how crazy it is, right? It's not just point and click. I can actually, if I do show run, or show run, there we go. I can actually get the configuration. Now right erase. Look, War, you're not being helpful at all. I have the ability to configure this switch with the CLI, which is very often what you'll have to do. All right, so all my links are down. All right, perfect. So what I can do is I can make a connection. Look at these connections. Copper straight through should be fine, right? I don't need crossover cables in 2022. From my router, oh, I get to pick the port. So I'm going to pick from 01. PoE on that 3652. That's right. Really, really cool. Power over Ethernet. Huge win for us. Meraki does not have CLI. Yeah, so they have Meraki gear in here, and I'm not using it because we're going to attach the connection to the first switch, or the first switch port on this switch. Good. Thank you for that beautiful cable management. Okay. Now it is down right now. Is this on? It is on. But it's not doing anything. So I'm going to make another straight through connection from here to 000, and that's my WAN uplink. Let's go to the logical. Which standard are we using? B. Yeah, we are using T568B as our standard. Now let's clean this up in the logical view, just so it's easier to see. And we can move these around in the logical view, so it's a little bit saner. What kind of psychopath uses T568A? Yeah, I don't know. I think it's from back when you did need to make crossover cables. All right, so this is down. And one of the reasons it's down, I'm going to move actually all of this over here. I'm going to move Husky stuff over here in the logical view. And the WAPs are going to be over here. Yes. Good, 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 good. And didn't we have classroom PCs somewhere? Yeah, there we go. Cool. E3650, 24, no PoE, 3850. The 3850 you're going to have fun with, Ted. I love that switch. It just occurred to me that it might be a little bit weird to have an emotional reaction to switch models. I've lived a bad life, I think, is what that tells me. All right, so we're going to do the cloud, which is the internet, and we're going to just call it the internet, which is this cloud pt empty. And what we can do with that, if we click on it, is we can just like add whatever kind of connections we want to it. It's pretty wild. So what we'll do is we can even do fiber. Yeah, have a look around. Welcome to the internet. There's our coax. So the coax connection is what we're going to use. Oh, can't add a module when the power is on. Off. Add a coax so that we get the cable connection down into our cable modem, right? But we are also going to add a bunch of fast gigabit Ethernet. I don't want fiber. Yeah, perfect. So we're going to add some gigabit ports on here so that I can add fake web servers, basically. That's what I want to do with that. That's for our cloud emulation. And I can connect a switch to that if I want, but I don't really want to configure that stuff because it's the internet. It's not part of what I'm doing. But what I do want to do is create a connection between the internet and our router. So I'm going to choose a coaxial connection. Boop. And down into our router. Whoa. Nope, that's wrong. That's not right. Cable modem. There we go. That's the way that's supposed to work. Okay, so one more time. Coaxial. By the way, something to think about, and this is the point that I really want to drive home for the security folks. How many times have I said the word security since starting Packet Tracer? Just now, right? Just now. And that's because my first objective is to make the thing work. I am a plumber. The thing's got to run. Flow has to happen. And then we can talk about what isn't supposed to flow. You know what I mean? Exactly. Now, I'm not going to pass judgment on whether that's the way it should be, but it definitely is the way it is. All right, we've got this cable modem. Now, in order for us to start making this thing work, we need to start making some IP configurations, right? We're at that point. So the first thing I want to do is for my base router, I'm going to give it... Is Husky's espresso machine an IoT device? Yes, it is. That's why we put it on there. Time to make some configurations. I love this part. So the first thing we need to do is for our gigabit Ethernet port 0. This is our WAN uplink. So I can give it whatever IP address I want. This is, for all intents and purposes, this is my WAN IP. So I'll call it like 100.200.3 not 300 .100.50, right? And I'll put that in a subnet mask like that. So it's just like a massive, actually it'll be on a /16, assuming there's like an interchange somewhere. And I want to pause right here because we're talking about networking, and I know that this can be something that folks struggle with. As we go, if there's something about the networking that I need to explain or that we need to go over again, please don't hesitate to ask. And that will include IP addresses and how they work and subnets and how they work. Because we're kind of just tossing them in here right now, but it does matter how they work. Okay, so this is my WAN IP. Hey, Game Date, thank you so much for the follow. And then interface 1, this is my LAN, essentially, access. So to start, I'm going to give this a 10.1.0.1 because this is my gateway. This is the thing that our data has to get to in order to get out to the internet. And that's going to be on a /24 network. Actually, just kidding. In an environment this big, a /23 network. Is it normal to have a WAN network that big? Yes, it is. A /16 is absolutely reasonable for a WAN network, depending on how your routing and your interchanges are handling it. So that's up to your ISP, right? Okay, 254. I'm changing my mind. Just for simplicity's sake, I'm going to put it on a /24 network rather than a /23. All right, that looks good. And we have another interface here, but we're not going to mess with it just yet. I can, if I need to, add, I believe, additional ports as necessary. Ooh, great question. What are the practical differences between two hosts communicating on the same versus the different subnet? What an amazing question. Okay, for that, I actually want to draw because we don't have the gear up just yet. So let me get my handy dandy G-Ink open so I can draw. Okay, so two different subnets. Wow, what a cool question. So I'm going to come down here for a little bit of drawing space. Okay, so let's talk about the kind of equipment that we'd be imagining here. So two different subnets. So we're going to make a router. Okay. And the router has two different network interfaces. Okay. This is interface 1. And this is interface 2. I know this is really bad drawing, I'm sorry. And I'm going to make a laptop that is on interface on the subnet 1, and another laptop that is on interface 2. Now, each of these subnets, is it normal to have two interfaces or go with router on a stick? It's pretty normal to have two interfaces. Because don't forget that your firewall can also be sometimes considered your router. We're not doing that right now for reasons, but so for example, if you were using a tool like a Palo Alto firewall or a SonicWall or even like a Juniper or Barracuda, those they can serve as your network edge, right? So they can handle routing and the security all in one appliance. And the way that they would do that very often, like if you want to send data to a DMZ versus to your LAN, that would be on a different physical interface on the appliance. So yeah, it's pretty normal to have that happen. And we haven't even gotten into virtual interfaces, which is a different sort of thing, but also can come into play. Now, so this machine right here, let's say it has an IP address of like 10.1.0.10. Okay, so, and it's on a /24 network. Meaning that only this last octet is in that subnet. So 10.1.0. Practically 1 through 254 are the IP addresses that are not broadcast, but that are available in that subnet. And let's say that this machine over here has an IP address of 10.2.0.10. And again, it's a /24. Now, each of these subnets has to have what's called a default gateway configured. And that, in our tiny little network here, is going to be this router. Or, yeah. So this interface here actually has an IP address of 10.2.0 10.0.1. And this IP address over, or this interface over here, has an IP of 10.1.0.1. Now, let's say that I make a request from this machine up to, and I'm going to make the request for, let's actually not be in our subnet, just to give that an example. So I'll make it to quad 8, right? 8.8.8. I can't draw 8s, sorry. Oh god, oh god. 8.8.8.8. So I'm left-handed, and but I use the mouse right-handed, so when I try to write, it's just a disaster. But the point I'm trying to make is, this is definitely nowhere in either subnet, right? So the router's going to say that, and like, I have no idea. So I'm going to send you to my default, which is outbound. I'm actually not Husky. If I'm writing left-handed, I'll do one of these, but I can't do that super well, so it often ends up looking like a 9, so I try to do circle 8s. Anyway, that's going to go out, right? But, if I make a request for 10.2.0.10, I also don't do the 0 slashes or the 7 slashes. But if I make this 10.2.0.10, right, the router will be like, oh, I have a routing table that says that packets destined for this subnet go to this interface. So I'm going to take that and say, down you go. And if it's doing all the routing, it will also have an ARP table that says, I know where to send that. Right now, there may be a switch later on down the line that will handle what switch port to actually send that packet to. But if it isn't, then it's just like, off you go. And if it goes to a wireless controller, then it's just broadcast to everything on the radio. But that is how routing across subnets works. And again, your router isn't going to stop that from happening unless you have a rule to stop that from happening. It is designed to route, right? And switches are designed to do some routing as well these days. So just be aware, like, that is what is happening across subnets. Okay, that was fun. Let's move these business PCs up here. Okay, so by default, that will route the 10.2 traffic to the 10.1. Yeah, if it's addressed that way. You don't need to. So Nefarious, the router, if you're doing normal stuff and you're setting up your interfaces that way with those IP addresses, you won't have to manually create those routing tables anymore. Yeah, exactly. Those are normal automatic routes. You can do static routing to get kind of crazy if you have specific things that you want it to do, but those kind of defaults you don't have to worry about manually. ZQ asks, so is it mostly an organizational tool, or do you set different rules for different subnets? It's absolutely not just an organizational tool. You will do different things on different subnets, and you can also completely separate classes of devices with subnets sometimes, as well as virtual LANs, which we'll maybe get to today. I suspect this will not be the last time we use Packet Tracer. Okay, so this is still not playing ball. Let's see. Let's go to config. We've configured this, and we've configured this 10.1.0.1. That's all good. And I've got a, let's see. Oh, I think I know why. I have to go to my coax. Do I have to administratively set this up? Is that on the router? Yeah, hang on a second. I have to turn it on. There we go. I have to manually enable. I could have done that with the CLI too, but enable the interface. So 0 is up and 1 is up. Cable modem, sort of the same deal. Is this off? We ran a coax connection. Oh, you know what? I might have to enable... I have to turn on the internet. I literally have to turn on the internet. There we go. So good. Okay, so check this out. We have data flowing from the internet to our modem, to the router, and then to our switch. Why have different subnets on the same network? What purpose do they have? So subnets can have either a like data separation value, or they can have logical separation value. So for example, I will often give my wireless clients, I'll put them on a different subnet. And so a couple things that allows me to set up not just access control across a subnet, so I don't have to do like, oh, just these IPs, but I say this whole subnet that I've assigned, like I can set up rules based on that subnet, right? To shape traffic and route traffic and deny traffic. That's one reason. And another one would be kind of a conceptual grouping as well. One of the things that you'll end up doing if you start designing networks is that you'll get familiar with what IP addresses are in what subnet and what those subnets mean. So for example, like, as I said, I want to be able to look for an IP address and say, okay, that's like a wireless client. I know that. Or, oh, that's in my business subnet. Hey, Matt, good to see you. Glad you could make it. We will not be starting over. Does Packet Tracer allow you to use your internet connection to simulate external access? No, it doesn't. It's really because, I mean, that's kind of where it ends, right? For Packet Tracer, it's the this is a CCNA and CCIE study tool, right? And so generally speaking, it's about your internal network. But we're going to fake it with this fake cloud here. We're going to make some internet servers to do it. So you can kind of do a simulation that way. It's pretty cool. Okay, so router looks good. We have our multi-layer switch here, our 3560. And now we can start setting up some connections. Now we're going to set up connections to our PCs. So we'll do, a copper straight through connection. And I'll put that on, what switchboard do I want? Maybe I don't want to do that just yet. Let me ask. So I'll ask this question. If I wanted to start connecting devices, right, to this switch, and I can in fact do that, but what might happen if I try to turn on one of these PCs with a connection? Yeah, let's do just that. I'll do one PC. So I'll connect it to port 3 and send that to my PC here. The PC's booting up. Will I be able to make network connections? In fact, let's do another one. Let's do a copper straight through port 4, and we'll put it on here. No, nothing has it. So the issue right now is that Husky's PC and my PC don't have IP addresses. Now I can statically assign them, but that's really not the ideal situation. So we're going to set up, we can also set up some routers have the ability to do DHCP. This router might not, and some switches even have the ability to do DHCP. Yep, you all have it. So I'm pretty sure the 3650 can do DHCP. I hate doing that though. This is just a personal thing. Like, you can do, like, let your switches do switching stuff, right? Don't try to add, even though the Cisco's have the ability to do a bunch of other stuff internally. DHCP on router and relay from switch. I'm going to argue not even put the DHCP on the router. And here's why. The router's a little bit underjuiced. I would say have a separate DHCP server that is much easier to manage DHCP pools on. And that can have multiple interfaces if you need to have, you know, different kinds of subnets being assigned that way. So for that reason, we're going to go back into the physical view and see if I can add. Can I rack mount a server here? I can. Love it. Look at that rack mount server. Okay. So this thing is going to be, and this is our main distribution frame. Yep. This is the MDF. So we're going to say, okay, this server, we need good names. It's massive. It's like an 8U. I can't believe how big it is. But we need a good name for this thing. Like any good network architect, we have to think of a good theme. Name after birds? Interesting. Birds. Shrike. Yeah. Okay. I think we're gonna do synthwave bands. Which means that our big bad primary server definitely has to be Midnight. So we're gonna statically assign this thing's machine, this thing's IP to 10. I totally forgot what subnet I'm working on. It's 10.1, right? 10.1.0. I'm going to give it 2. And the DNS server I'm going to leave alone at the moment for reasons. And we're going to not mess with IP6 right now just because I don't want anybody's heads to explode. This is the global settings. And I think that should be all right for the global. Now, this is so cool. I love this part. I don't know. I'm just such a geek about stuff like this. I think it's so neat that you can activate services on the server like this. So I can even set up a web server, which we'll do for the internet. But there's DHCP right now. I'm going to turn the HTTP server off, though, because we don't need it. But I do need the DHCP server. And I want it on. Okay, the default gateway is going to be 10.1.0.1, right? Our router, 255.255. Oh, nope. DNS server we're going to leave alone. The start IP address. This is the start IP address of our pool. Now, this is, again, this is like a me thing, where I like to start my, if I know that I can get away with it in terms of my subnet size, I like to start my IP address pool up at 100 rather than at 0 or 10 or whatever. And the reason I like to do that is because that gives me a little bit of space for statically assigned servers that I know I'm going to want to have statically assigned in the environment. Is this similar to a CIDR block? It is similar to a CIDR block. What we're setting up is the subnet size, hoist 777. So, the subnet mask, which we'll set up here, is 255.255.255.0, which, chat, what's that in CIDR notation? Correct. 24. Because 24 bits of the subnet IP address have been masked off, right? 8 here, 8 more here, and 8 more here. So we have 24 bits masked off, leaving us 8 or 256 digits, but really 1 through 254 effective IPs, not counting 0 and the broadcast. And so our start IP address for the pool, though, the DHCP pool, is going to be 10.1.0.100. And that's because, as I said, I want to leave sub 100 for my statically assigned stuff. That's just a me thing. You don't have to do that. That's just how I always like to build out these subnets. It works for me. Okay. So DHCP is on, the interface is... It's funny this fast Ethernet. This is only 10.100, so it's going to be slow, but whatever. Can I change that up? Yes, I can. Okay, turn you off. Let's get rid of this. Yeah, I want the gigabit Ethernet, you know? Let's power it back on. Are there any good books on the ins and outs of developing peer-to-peer networks? I'm sure there are, but Atom Fighter, I don't have any that I can, off the top of my head, recommend to you. But perhaps someone else in the chat can, or perhaps someone in the Discord can. Let's go back to our services in DHCP. Yeah, see, now it's gigabit Ethernet. Kind of wild that by default it's like a 100 megabit connection as opposed to 1,000. So now that's much better. Oh, but we have to redo the... Dang it. Okay, that's fine. LAN pool, default gateway, 10.1.0.1. I'm going to have to reassign the 10, 1, 0, 100, 255, 255, 255. Maximum number of users is wrong, but whatever. The subnet will figure that out. Good. Save. Okay. We're going to remove... The server pool is off, though. I'm going to turn that off and then turn this one on. What the... Oh, that's weird. So I can't rename the default. Do you need a registered Cisco account to download Packet Tracer and play around with it? So, no, but it's free. You can sign up for the free account and you can still use Packet Tracer. And, but there is one of the things I found is the Linux version, like, weirdly doesn't open up the web browser to allow you to authenticate, even if you have a legit account. So there is a bit of a trick. If you start Packet Tracer without being connected to the internet, it won't ask you to sign in. And you can block the connection from, Windows Firewall if you want to do it that way, or just disconnect your Wi-Fi if you're on a laptop or something. Like, it sucks, but it works. They do release the tool for free. All right, that's going to get weird. So I'm going to actually remove the server pool and just call it. Okay, so they don't want me to change this. 10.1.0.1. Probably need to do an on-off. I don't know. Can I just save this? Yeah. No, it's just called server pool, which fine. I can live with that. Hey, Salatnot and Fima and Zzip, thank you so much for the follows. All right, one more time with this. 10, 1, 0, 100. Thank God. Okay, great. So that's all looking good. And then I think we need to config the gig, the global, right. So now this needs to be reassigned to 10.1.0.2. All good. Anything else? I think that's fine for now. Radius might get interesting later. Now, let's go to desktop. And let's do a command prompt and just make sure that I can... So it looks like I'm also going to need to configure here 10.1.0.2, 255.255.255.0. Good. Back to my desktop. ipconfig. Hey, there we go. Now that's looking right. How wild is it that I have a command prompt on this fake server that I just invented in Packet Tracer? There's a lot of stuff here in Packet Tracer that people don't necessarily play with unless they look at every piece of this, and it's really amazing. You can even set up Python projects. Like, look at that. Let's mine CVEs inside of Packet Tracer. All right, so we're good here. We have a DHCP server. That was the point that I really wanted to get across. And there's the midnight here. And also, this is why I left port 2 unassigned. Because I like to... I'm a little OCD about my port assignments. So now we get to start assigning stuff. We've got a DHCP server up in the mix, which means once this thing boots up, oh, so funny, these fast Ethernets. They're still at 10.100. I'm going to power off my machine and replace it. You can, by the way, you can do retemplated. You can do retemplated machines if you want. You can use a machine as a template and then make that like the machine that you build out from here on out. So let me just power off this machine as well and replace this with the gigabit Ethernet. It doesn't really matter for our purposes, but I wanted to point out that at some point you will want to start thinking about what is 10.100 and what is gigabit. Yeah, so 3 goes here. Good. And 4 goes here. Cool. How do you connect the floppy drive? I mean, it's in there. I gotta turn this thing on. CDA, yeah. Let's see if that works. It should. If it's on. Nope. I don't think it's actually a thing. And it doesn't really matter for our purposes. I think it's just there. Let's get the command prompt. But look at this. We've got green across the board. I don't yet have an IP address, though. Which is concerning. The switch should just switch, you know? The switch shouldn't have to do much to make this work. Our links are up. So let me go back to our server and make sure that the HTTP service is on. It is. VLAN 1 is up. Oh, VLAN 1 is down. Interesting. Okay, so now we get to do our first switch config thing. I know this is a little bit small. But we're going to enable, which is like gaining root on the switch. And then we're going to do conf t, configuration terminal, and then int VLAN1. By the way, I haven't run these commands, no kidding, in like 4 to 5 years. No, FIMA, the computers are not set to... Oh, wait, you're right. FIMA's right. Yeah. It is set to static. Let's change that to DHCP. Good call. Good call. Change that up to DHCP. Good. And there's our IP address. Right, we shouldn't, the VLAN interface, we shouldn't have to bring up. The things are going to get tagged at or not tagged, I should say, with VLAN 1 anyway, so don't worry about that. Yeah, very, very good call. We just needed to change it to DHCP. And look, we're getting IP addresses. So DHCP is up and running in our network, which means, and the switching is working. And Big Mac, thank you so much for the subscription. And Anonymous, thank you for the cheer. All right, so what's cool about this is, let's see, Husky's PC is at 10.1.0.4. So from my PC, I'm gonna just ping 10.1.0.4, and I get data. So I'm confirming that my environment has an operational network, exactly the way that I want it to. Very cool. I'm gonna power this off and replace this with a gigabit Ethernet. Good. And I'm gonna do the same thing here. Turn this off, replace this off, and then give this a gigabit Ethernet. Good. Back on. And back on. And let's config our IP address here. So this will be 10.1.0.4. Looks good. And then Husky's server is going to be 10.1.0.5. Now, if I were doing this for real, as I was making these connections, there's a very, very important bit of documentation that I need to be producing. And this doesn't seem like it's a security issue at first, but it absolutely is. And I'm wondering if anyone can tell me what that is. An inventory, but say more about inventory. That's absolutely right, but I'm talking about a very specific kind of inventory. Access port, that's right. I want a mapping. MAC addresses I don't have to map, and I'll show you why. In our switch here, we can do show nope, get of conf, right? Show MAC address table. That's interesting. We don't have any just yet. Sticky MAC. No, guys. I mean, you're not wrong that those are important, but more to the point is I need a mapping of machines to switch ports if they're static. So MAC address, yes, but I also want to know logically what is that device, because MAC addresses can be changed. So MAC addresses I don't care about in the inventory for my purposes nearly as much as I care about what is the logical host. The reason being, I want to know if something different, right, is connected to it, even beyond MAC. Because as I said, MAC addresses can be changed. So don't rely on them. But you do want some sort of a signature of what kind of device is it, where is it? And also, let's go one layer up further. This is actually outside the scope of Packet Tracer. But this switch, let's go to the physical view. This switch, right? You can see these cables are kind of just like going out into nowhere, like in Spider-Man games where you can just like thwip into the sky. You're not actually connecting to buildings. But the truth is, where these cables would really be going is a patch panel. And the patch panel in the back of it would have this giant bundle of stripped Cat6 or whatever cables that are punched down. And then those cables are run through conduits and go out to the physical network drops in your building. So first of all, I want to have a mapping of my patch panel, my drops, right? I'd number them whatever way I want based on the building that I'm in. But I want to number them, and then I want to map them to the switch port on the switch. First of all, the patch panel number. And then I want a mapping of the patch panel number into the switch port as to where it's actually connected. So that's the inventory that I'm really talking about, is keeping track of where the physical wire is connected. Because over time, as we add more and more networking security tools, you're going to have to know what is connected where physically, right? If I shut down ports that aren't in use, which is absolutely something that we should do, right? Then I should have to know what ports I'm shutting down, meaning I need a mapping of the physical location of the port to my switch to know which switch port to actually disable. That's the kind of thing that you have to do. That's right. Data center infrastructure management. And there are tools to do it, but the truth is that I've even done it with like Google Sheets. And I've gone as far as doing like, I've made a Google Sheets template where these are cells. The switch ports are like cells in the spreadsheet, and I've listed them there, and then I have kind of a pivot chart to where they go. It's really fun if you're the right kind of person. Okay, so now port descriptions also need to be kept up to date. Very, very true. Absolutely. All right, so we have like a little LAN here. We've got 4 machines, well, 5 if we include Midnight, up and running. Now, what about our wireless controller? Actually, do we want to go wireless or do we want to go classroom? I'm going to call this Core 1. This is our core switch. And on that, we're gonna, off of that, we're going to send another switch. Let's make a new switch. New switches. Do a 3560 again. Okay. And this one, oh, device is still booting. Fine. Did I not get the right switch? I got a 3560. That's not what I wanted. Away with you. Give me a 3650. Thank you. Like for like. Now, in real life, you'll probably, in a big enough environment, you will have mixed models of switches, but for now, this is fine. Okay. What I'm going to do with this switch is handle... Oh, actually, you know what? Let's do the business office. I was going to do the wireless, but let's actually do the rest of the wired stuff first. So let's go to the business office. And notice that if we zoom out one level, right, we had the MDF, and look at how well this is connected now. It looks so clean in the physical. And this also looks pretty sane, right? That we have this going on. But now let's go to the business IDF, and I'm going to need to add a rack. And onto this rack, I am going to add a new 3650. And yep, let's add our power supplies. So good. And the device is booting. But this is going to be the switch that handles the stuff in the business office. You can imagine that we may want to eventually perform some sort of isolation between what's going on in the business office and what's going on elsewhere in the network. For now, though, we're not going to do that. We're just going to, like, let's get everything connected and working. The point is to show, like, what extra steps we need to take from a networking perspective to add network segmentation. So first we have to show it without. We have to show the null hypothesis. Okay, call this business 1. Now I have business time from Flight of the Conchords stuck in my head. Okay, all good here. And we haven't even gotten to VLANs yet. We'll play with that at some point. Hey, Nefarious, I'm glad that you're enjoying it. I loved doing this stuff. I loved network engineering because, much like programming, it was really, really, really hard, and it either worked or it didn't. But once you got it working, it was the greatest feeling. And then you kind of, like, you had your little network domain, and you were the lord of it, and you got to build worlds out of your packets. I don't know. It was a very enjoyable part of my IT career. And I still strongly believe that if you're trying to get into cybersecurity, this is bringing you back to your MOS school. Husky, you may want to explain for our non-US folks what MOS is. But I strongly believe that if you're trying to get into cybersecurity, that a good background in networking is something that's going to empower you for your entire career. Even if you don't get to, like, work as a network engineer or anything like that, if you start studying some of this stuff, play with Packet Tracer, learn how this works, you're going to be in such a better situation to understand how the networks that either you're defending or attacking really go together and how they work. Okay, so we have the business switch, right? Up and running. And from the business switch, let's go back to our logical view. There's our business switch here. So our logical view, let's make the business switch connected here. And I'm actually gonna... I wish I had done this earlier, but it's fine. Power this off, replace it with a gigabit. Power this off, replace it with a gigabit. Okay. And then config... Oh, right. Power these on. Power... This one is on. Power this one on. Good. Config DHCP. Config DHCP. Good. Okay. I got my business switch on. Nice, Cobra style. I love it. I love it. All right, let's get Husky's espresso machine out of here. It's in the way. But what we're going to do here is we're going to create a connection. I'm going to toss that on 24 to our business switch. Now, in real life, actually, can I really not get a fiber module for this thing. Oh, there we go. It's gigabit, but it is a fiber SFP, right? Yeah. Industrial Ethernet smart grid switches. Okay. There's a reason why I'm doing this, because this is real life. I would not, if I could avoid it, I would not trunk my switches with Ethernet. I would do it with fiber if I could do it. And so we're gonna. See how I have a gigabit Ethernet 111 now? That's my fiber. I'm going to have to add one of those to the business switch as well. Cool. In my MOS school, they had us put a lab network together, but they would have the instructors storm through the lab, be like, "Where's my internet?" Simulate the real world. That sounds right. There's something very funny to me about the concept of a gunnery sergeant yelling about IT stuff. Yeah. No, for sure. Everything we do in this SOC is done with speed, volume, and intensity. Okay. The gunny rolled sleeve. Okay, let's go. Fiber. Boop. And 111 is up. Cool. And now we're going to make a physical connection to our business stuff. Often, by the way, the business office is going to get special love. Like they'll get more IT stuff than they really need. That's me editorializing. Now, in this case, you may legitimately want to do isolation with this, so that's fine. Now, let's see here. Everything's good. But will this fiber line communicate? These machines are up. I'm getting a 169.254 though, rather than a proper IP address from Midnight. And our gig is up though, so that should be good. This link should work as intended. And we're not worrying about VLANs or anything, so even though this isn't a trunk port, it should link up just fine. Oh wait, it is. Did that just happen? Did that just happen? Yeah, that just happened. It just took us a second for the DHCP to give it. We're good. I just had to be patient for the DHCP lease to get assigned. No, that's a great question though, Nefarious. The interface does not need an address, and in fact, unless you're going to do management on that interface, generally speaking, or you need it to do some like specific static routing, it won't need it. That's something to be aware of. Like, you can assign interface IP addresses if you want, so, but we don't have to do that. So, for example, here, shall we do a bad idea? Shall we do a bad idea based on Nefarious's question? I'm pretty sure this is like the top bad idea. All right, bad idea time. We have to manage this switch somehow. How are we going to do it? Well, we're going to do it with Telnet. All right, in order to do that, we have to assign an IP address to this thing so that we can Telnet to it. Now, you can also... Hey, I know it's a bad idea, but I will put folding money down that there are still tons of networks out there that have Telnet enabled on their switches. Why? Because nobody wants to go through the trouble of setting up SSH on these things. It's such a pain. But the first thing we'll do is... Look, dude, don't come from home. First thing we're going to do is we're going to enable to become root. And then we're going to do conft configure terminal. And then we're going to specifically go to interface VLAN 1. Actually, let's exit out of this to show you. We're going to show int to show interfaces. And this is cool because it shows you the status of all of the interfaces running, right? Now, one of the interfaces, if we even hover over the switch, you'll see at the very bottom. Oh, you can't see the hover. Oh, yeah, you can. One of the interfaces that's described here is the VLAN 1 interface. What is that? What is that? Virtual local area networks are a technology that adds a little bit of data to the IP or to the packet to the Ethernet packet, really, that allows you to tag the packet with a virtual network. To say, and think of it as like creating channels within the same physical network. So it allows you to separate and create different kinds of rules for data that is traveling over the same physical network, but can be tagged differently so that it is handled differently. That's what VLANs are all about. Now, on Cisco switches, if you don't have other VLANs enabled, every bit of traffic that you're routing is going to be on VLAN 1. And so by default, that is the interface that you kind of have up and running here. It says it's down because we're not using it, but VLAN 1 is the kind of virtual interface that would represent this switch on that VLAN. As we start adding other VLANs, you have to add those interfaces as well. But for now, we're going to mess with VLAN 1. So to do that, we're going to do enable again, and we're going to do configure terminal. By the way, in the Cisco CLI, if you ever want to know what you can do from any point, you just press question mark and it'll give you exec commands. And like many other shell interfaces, what you can do is you can kind of only type in as much as you need to make the command unique. So I don't have to type configure. I can do just conf, because I can't do con because connect exists, but conf is unique. So conf and then after that t for terminal. That's kind of how that works. So the full command really is from here configure terminal, but I'm just doing conf t and that works fine. Okay. And then from here, I get to specify an interface. So I'm going to do int VLAN 1. And now you can see I'm in config interface mode, which means I'm doing configurations for the specific interface. What can I do from here? Well, for one thing, I can say I can turn it on. I can enable this thing and I can give it an IP address. So first thing I need to do is I'm going to do IP address. And then I give it the IP address. So I'll say it's 10.1.0. Let's say 90. Okay. And then we give it a subnet mask of 255.255.255.0. Okay. And then I still won't be able to access it because I have to turn it on. And this is maybe my favorite thing in Cisco configurations, to turn on a switch or a switch port. Nope, not up. No shut. So you negate the shutdown command, and that is how you bring up the switch. Or that's how you bring up the interface, I should say. with that done, you can see that VLAN 1 is now up and it has an IP address of 10.1.0.90. And to prove the point, let's go back to my command prompt here, and I'll ping 10.1.0.90, and I'm getting a reply now from that IP address. And I'm pretty sure the telnet is not up by default, unless it is. No, it's not. So I have to enable telnet. To do that, I'm back in here. Shut, no shut. Yep, that's literally the Cisco version of turn it off and turn it back on again. God, no shut really is the, like, tell me you're a Cisco engineer without telling me you're a Cisco engineer. That command is so weird. Should you always shut down unused ports? From a best practices answer, definitely yes. But your business reality may be a little bit different. If you have a lot of people who are moving around, if there's a reason why people are using ports all the time. So for example, if you have a classroom that for whatever reason has Ethernet ports, right? And they're not used all the time, but maybe they are, so for that, you would add a different kind of security control. Maybe NAC or 802.1x would give you the ability to control what can use the port without shutting it down entirely. And we might have to do that next time. I don't think we're going to get to NAC today. That'd be wild if we did. By the way, just get a vibe check. How's everybody liking this? Are we enjoying this material? Are we finding it interesting? Is it too deep or is it too high level? I just want to know where we are as an audience. Yeah, Ted's right. In a data center, definitely shut them down. All right, cool. Seems like mostly thumbs up. Yeah, I mean, this is really complicated stuff. I know that, it's so funny. When I did the thread about network segmentation, when I did the thread on network segmentation, it was so funny because there was kind of two different responses. I mean, people were happy about it, but people were like, isn't this just basic stuff? Isn't everybody doing this? And then there were a couple of other people who were like, this is really complicated for a small to medium-sized business to get this all set up. And guess what? Both are correct. And so even though it might be basic for you, if you've been doing this for a long time, this may be something that a lot of even folks who are responsible for networks haven't had the chance to do yet. I can't tell you the number of people who haven't had a formal networking background, including myself, who become responsible for enterprise networks. And then what do you do in that situation? Like, how do you learn it? It's really freaking hard. The CCNA isn't cheap, right? And it can be a big deal to do that if you have a full-time job, if you've got a family to take care of. Like, there's a lot that goes into this. And so what may be basic, fake it till you make it, doesn't really, I've done that, but it doesn't work on networks because either you got it right or you didn't. But yeah, very often the fake it till you make it means that you're going to have networks that don't have best practices in terms of segmentation or even subnetting, any of that stuff going on. Okay. So let's go ahead and enable Telnet on this thing, just because it's going to be fun. So let's exit out of the interface config, and then we're going to configure line, right? No, I do want to be, yeah, I'm in conf t, and line, right? Yeah, line VTY for a virtual teletype terminal. By the way, I don't know if anyone knew this, but the TTY, yep, thanks friends, line VTY. The reason why we call it that is because it's a pseudo teletype terminal. And if you're too young to know what a teletype terminal was, I have to show you. that remember that before we had monitors, we had computers before we had monitors, right? We had computers before we had screens. And when you were connecting to something like a mainframe, you did it with a teletype terminal. And what it did was it literally printed out the commands, the input and output that you were sending to the mainframe. And it did it usually over essentially a phone connection. This is a teletype terminal. Whoa, don't need that. That's the deal. So when you see TTY or PTY or VTY, the TY is referring to the teletype terminal component of it. And then eventually it became, a cathode ray tube monitor. But before we had these available, it was paper. This is how you connected to mainframes. I just think that's so cool. I don't know. I'm into that. So yeah, line VTY, and then I think it's 0, right? Because the next thing you do is how many? Yeah, the first line number. So line VTY 0. And then we set a password for the line, and we'll call it Cisco 123, because if you're doing telnet, it's not like you're gonna have a good password. And then we'll set up login, right? Yeah, enable password checking. So we're gonna enable password checking with login. And then logging, this is kind of cool. We're gonna do logging synchronous, and that prevents like log messages to interrupt what you're typing. And then what else? We'll set up the timeout exec, right? Exec timeout. Yeah, exec timeout. 10 minutes is fine. And then we wanted to show the message of the day banner, so why not? MOTD banner. And exit. Write run. No, that's not a config. Write run. Write ton. Come on. Why am I brain farting? Right, mem. Thank you. Thanks, no nothing. We can also like save the existing config, but thank you. Right, mem. Okay. So now this thing is enabled for telnet, which means if I come back to my command prompt here and try to telnet to it again, look, I'm getting a password prompt, Cisco 123, and now I am set up. Copy run start. That's the other one I was thinking of. Thank you, Ted. Copy run start. So that's a really bad idea. Don't do that. Don't enable telnet, period. But definitely don't enable it on the your LAN subnet. Yeah, copy run start. That's the one that I was thinking of. Thank you. Yeah, that feels right. That's what I'm used to doing. In truth. Hey, Chad. How did your stream go, by the way? This is me rediscovering my roots in a lot of ways. I haven't done this stuff really in a couple of years. I haven't had to because I've been, doing pure security stuff. But I think it's cool because this is an interface that a lot of times security folks won't get to see. But it's something that in another aspect of IT lives and breathes all day, every day. Okay, so we have always use telnet on WAN. Yeah, exactly right. Destroy worlds. I mean, you can look up how to set up SSH. You can do it. It's just, it takes a lot more than setting up telnet. You have to set up your keys and do the whole thing. Okay, so our switch is working. Our business switch is working. I think it's time to go wireless. And for that, we're going to go back physical, and we're going to go to the MDF, and we're going to add the wireless controller. Wireless devices, no Meraki. So here's our wireless controller. Perfect. Perfect. And what is this? Now I'm gonna give this a name too. So wireless. What's a good synthwave band name for the wireless controller? Oh, FM84. Oh, this one gets gigabit internet. Hey, Tycho, thank you for the follow. And it's on by default. It's cool. Wireless LANs. Look at this. Okay, so we're going to do pretty fly for the Wi-Fi. I like it. We need to connect this to a thing. 257 A's. The SSID. Taggart Wireless is going to be the SSID here. Oh no, that's over here. Fine. VLAN is going to be 0, which will be untagged. So that'll turn into VLAN 1. Wu-Tang LAN. Some of you have really confusing ideas of what synthwave is. Although now, Husky, I'm trying to think of a network segmentation joke for the 36 chambers. So thank you for that. We'll do WPA2 for our authentication. Or WPA2 PSK. And the passphrase is going to be Taggart Tech. This is really bad, right? But there are a lot of networks that are set up like this. So what we've just done is we've created a network. This is just like setting up a home network, right? Where we set up the wireless, we're setting up the passphrase, right? This is how you would do it at home. But there are a lot of businesses that are small enough that they can get away with this. We will strengthen this as we go, but this is where we're starting. Dope. Okay, love it. And then in terms of DHCP, it's off. Okay, this is good. Central control, central local switching, local authentication. All right. And we can assign DHCP with this if we want, but we're not good. Not yet. We're going to do flat and then we'll segment it out just to show you. Interface is management. Okay. Looks good. All right. Time to connect. So here we will connect our... Oh, I do have a table. It's so funny. Every day I'm buffering. I love it. So there's a little wireless controller. So we're going to add the straight through from here up to our port switch. And we'll toss that onto... I like to do my server stuff toward the end of the port range. Oh, this is the internet. It's so funny that the internet is actually on the rack. That's incredible. I guess if I wanted to, I could have zoomed that out. Because this is my multi-city view. Right? And if I go to my organizational tree. Yeah. I could have moved one of these around. At least it doesn't weigh anything. That's true. Oh God, Ted, I know. It's a nightmare. And I can't change it. I cannot like make this a vector where it's like straightening down or using the built-in cable management of the rack. I can't do that. And I'm going crazy. So I want to connect this to here. Cool. So we've got this going, and then we're also going to have to, we'll do go to logical. We're going to connect our WAPs to this as well, because we have, where's our wireless controller? FM84 is up here, right? Now this thing isn't a switch, it's a wireless controller. So what we're going to do is we're actually going to run connections to our access points like so. Now you think that maybe we would have a separate switch for the wireless? If you could afford it. I would love that to be true. Not always possible. All right. There's our wireless controller. There's our wireless access points. Looks good. Let's move the router over here. Put FM84 up here. Hey, Orbital, thank you so much for the gift sub to Sparwall. Really appreciate that. All right, now let's see what's up with FM84. We have a default group of access points, and if we go to our wireless access points, they are connected. Right? Port 0. One of the things that's kind of cool about these is that they have 2 ports. All right, so the question is, how do we get access points? Here we go, the management. So we're going to call this 10.1.0. What are we at? Let's call this 10. And the default gateway is 10.1.0.1. Now we haven't even gotten to DNS yet. Okay. That's good. And then these guys. see what this shows us here. Port 1 is up. And it's on, but we're not getting any data here. Let's see what happens when we turn this thing on. How does it not have a wireless? God, look at this laptop. This is like a ThinkPad from 1998. Turn it off. Give it this wireless out here. It's so good. Hold on. That's a 2.4. Let's give it an AC interface. Cool. All right. And then power it on. Nice. All right, so it's on. And let's see what happens when it tries to authenticate. Ah, look at that. It's hitting the access point. Now, it's not going to succeed. Oh, it is succeeding. Because the controllers are not getting controlled by this. Unfortunately. These are essentially just acting as dumb switches. All right, let's remove this and put the AC access point back in. Wireless is happening. Now, that really shouldn't be happening that way. Because we've gotten oh, the DHCP pool is wrong. That should be at 100. Yeah, that's why that was a problem. Our DHCP addresses should be... Thanks, Matt. Really appreciate it. All right, so let's turn these other laptops on. And I'm also going to show you how to make a template device, because that's really annoying. I don't want to have to do this again. Power off. AC. Okay. Power on. Cool. And then here's our device templater. So the access points are just bridging, right? They're not NAT. That's correct. To create a template device. So we're going to hit select and then do the laptop here. Call it AC laptop. And it is an end device. Top with AC Wi-Fi. Cool. Now the reason I do that is because now I have this AC laptop, right? That means that I don't... Ooh, let's no to that. Now I have this template here that has that wireless AC that I don't have to worry about ever again. I could do that with PCs as well. Much handier. So if I do this again, I select my PC and call it GCP Gig Desktop. And that's an end device. So just easier to have those at the ready, right? So we have a networking. Now I got to figure out what I'm doing with this controller here, because it should be picking up these AP groups, right? And if anyone knows what I'm doing wrong about that, please let me know. But my understanding, I actually haven't worked a whole lot with Cisco wireless equipment. Though my understanding is that it should be finding access points on the network and just going to work. All right. It does have Wi-Fi. Our espresso machine does. Why isn't it on? Why isn't it picking up wireless? All I'm saying. It's got files. We're obviously doing flag.txt on the espresso machine. That's for you, Husky. Incredible. IoT server. Oh. Look at this. Okay, so the wireless... Oh, look at this. So, wait. The SSID, we have to connect it to... Should be like that, right? Oh, look at this. There's an advanced. Alt-click to interact. Thing editor. Oh my God, look at this. If we... Look at this. Look at this. Okay. So it's got power, right? Config. Thing editor. Component name. We don't have to do this. But we can give it... Can it actually run Python? Yes, it can. Oh, it's got... Look at this. It's got a main.js. Look at this. Look at this. So it's got state. That's incredible. Okay. Oh, look at this. It's setting state from the JavaScript. Look at that. That's so fun. Custom write 0 state. Set device property get name. That's so fun. Okay, that's really cool. So we could set up a thing where, like, if you trigger the function, hate to be the guy who had to write this. I bet there's a lot of eval under here going crazy. Yeah, I would agree. Oh man. So look, the state is set here. That's so cool. Oh, this is like on off. That's so fun. Look at this. And then alt click to interact, right? So, oh, alt click turns it off and on. Wireless is up, and the question is, will it pick up the wireless? Now, yeah, it was a self-assigned. Now, it's covered by wireless. Wasn't TaggerTech the password, not the SSID? Let's find out. Taggart Wireless, you are correct. But here's the thing. I don't think it's going to need it. because these devices, right, are not, they're saying SSID default. Do CCNA labs use packet tracer? Yeah, they do. Oh my god, did you see that? I don't know if you saw that. The coverage range on meters is 140. That is a straight up lie, especially for 5 gigahertz. That is not true. 5 gigahertz wireless does not go 300 or 140 meters. It doesn't go 100 meters in anything like real operations. 5 gigahertz Wi-Fi in a building, that's like 1 or 2 walls, and then you're done. Five gigahertz is much faster, but because of the nature of the frequency, it gets knocked down way faster. 2.4 goes for a much longer distance. That's so weird. I'm gonna quickly just do a lookup here. Packet tracer. Oh, this is funny. So 10.1.0.10. Check this out. If I go to 10.1.0.10, the server reset the connection, but I can get the web interface of it. That's so good. Let's confirm that is the right IP address. Oh, on the management interface, though. Which is not what I believe this is connected to, right? Yeah, it's connected to Gig 0. There's just this. Okay, interesting. Oh, but management should be good. I mean, whatever. Curious. I'm still curious how to set up the AP groups, right? That's the trick, is how do we set up access points? Lightweight access points, automatic registration. Lightweight are directly connected to layer 3. Am I using the wrong kind of access point? Perhaps I am. So let's go to network devices, wireless, lightweight access point. Let's use one of these. So we're gonna actually blow away these WAPs, and we're gonna reassign them. Ah! I deleted too much. There we go. Now let's try just one. Lightweight access point. Okay, I'll take it. And then can I... We'll move this around. Still not seeing it. I can't undo that far back, unfortunately. Have all been IP addresses been reset? No, I don't think they have. But I also don't think that is a deal breaker here. But fair enough. We'll power off machines and power them back on. That's static. Anything DHCP related. All right. I would like to get the wireless working, and then we can, I think, call it a day for today to build our flat network. And then we will start messing with segmentation next time. Yeah, I'm not seeing them. I love that most of the example, like the answers when you Google for this, are YouTube videos, because there's a big market in CCNA training, which I'm not really trying to compete with. This should be good. Let's try again to see if I can get to 10.1.0.10. Nope. Server connection reset. Oh, hey, but look. This did provide wireless connection to this. Where is that access point? Oh, it's in here? It really shouldn't be. How do I move it? Let's put another lightweight access point in the hallway here. Go back to logical. We'll do a straight ahead connection. Put that over here. Now, actually, this should be work. Oh, nope. 169.254. Yeah, these aren't actually connected. Now, interestingly, these are getting IP addresses, or it was, right? So 1.103, and that's fine. I mean, you can do it. You can have the lightweight access points either be DHCP or set them statically, depending. Hmm. Oh, look at that! Look at that! Look at that! We got access points. So this is actually working. Let me untag the VLAN here. See if that makes any difference. That did it. If you so don't tag the VLAN on your WAPs. And now look, our espresso machine has uplinks are all untagged. Yeah, that's right. But I mean, everything is really VLAN 1, but the wireless still considers 0 to be untagged, and so that's kind of the deal. Yeah. All right, so we have our espresso machine. What about our laptops? Now the laptops are not working because we have to configure their wireless. The SSID is wrong now, right? Because now we have to say it's Taggart Wireless. We have to give them the right password. WPA to PSK. Taggart Tech. That should be good, and we may... Yep, there we go. That immediately gave it a connection. Finally, we can all SSH into the espresso machine. Well, what we can definitely do, we'll do it from Husky's machine, is let's start 10.1.0.109. So let's go to ping 10.1.0.109. I took the easy way out for now, the Guar. The point is to build a bad flat network, and then we'll segment it and add the right security stuff to it. All right, so we can ping to it. But what else can we do, right? Does this thing have a web browser? All right, not saying that name out loud, but thank you for the follow anyway. Server reset the connection. Can we mess with this anymore? Can we like add extra stuff to it though? Oh, hell. That's Telnet SSH client. I don't want that. I actually want the... Honeypots, thank you so much for the gift sub. We'll get rid of the desktop. Appliance, IOE client, on input receive, process data, touch interrupt. So let's look at the specifications for how this works. Registration server compatible. Connect appliance to SBC or button and send a custom write to turn on off the appliance. Oh, hilarious. Connect device to MC USB-C thing. Use the custom write API per data. So you can write IoT controls for this. That's wild. Let's add another IoT device. What else we got? A humidifier, a lawn sprinkler, a light, motion detector, portable music player, solar panel, webcam. That is a window. I thought that was a sliding door. I'll put a lamp in my office. I believe there is an air conditioner. That's a garage door, furnace, carbon monoxide, Bluetooth speaker. Ah, AC. There it is. Top one. I thought that was a microwave. Bluetooth speakers are the worst, by the way. I would never have one in real life, but we're gonna put one in here anyway. Config wireless. SSID is gonna be Haggard Wireless. PA2. PSK. Okay. What's wrong with Bluetooth speakers? Why would I want cloud services to have spying devices in my network? When I say Bluetooth speaker, I really mean the Alexas and Google Homes and things like that, right? And even the Apple speakers. I don't want them anywhere near my network. Are you kidding me? Let's try on advanced, see what else we have here. Bluetooth compatible, pair of Bluetooth speaker with portable music player through Bluetooth using config tab. That's so funny. You can do a whole Bluetooth thing. All right, we can go down the IoT rabbit hole later. And look, after like 5,000 clocks that'll connect back to Bluetooth. Oh God, why? All right, so now, look, we've got this working. But unfortunately, you know, can we get to stuff on the internet? That's quite the question. To find that out, what we're going to do is we're going to create a new server. And this is going to be kind of like a fake web server. And we're going to put it out here in the cloud. It's kind of interesting that it's the internet, but whatever. So web server, and it's static. And let's turn it off. Get rid of this. Give it a gigabit Ethernet connection, not fiber. Just one of these is fine. Power it back on. Cobra Style, there was I wonder if it's still around. There was an open source project that was making them out of Raspberry Pis called Mycroft. And so it is a Bluetooth speaker, but it also, and it's, yeah, it runs off of a Raspberry Pi. But it also does some of the voice assistant stuff. It's pretty cool. You might want to check it out. Sci-Fi, thank you for the subscription. All right. So we're going to configure this static. We're going to call this 100.200.100.123. Wait, was that what I made the internet? 24, maybe. Tiberius, thank you for the follow. And we'll put that also in the 255.255.0.0, that big /16. It's out here on the internet. All right, that looks good. And then services. Yes, the HTTP server is on. We can, by the way, import files for the HTTP server. We can have it host whatever we want. How crazy is that? All right, looks good. And we can also set up a host firewall, which we haven't done much of yet, but it is something we can do. NetFlow collector, so good. Okay. Okay. Let's make a connection. In this case, I believe we're just going to do, yeah, one of our gigabits here. Connect that to the internet. Don't buy switches without NetFlow. That's right. I love StealthWatch. Honeypots, thank you for the cheer. Really appreciate the 200 bits. All right, now in theory, this thing is up. And what does the internet have? Right. Provider network should be cable, I think, for these. Almost all of them. And there's a reason for that. Good. And then the frame relay for cable is coaxial 5 should go to gigabit Ethernet 0. So what we've done here, yeah. Perfect. So we're creating a frame relay saying anything that comes from the coax, which is our here, should go to gig Ethernet 0. That should work okay. No frame relays here. All right. If we've done this correctly, I should be able to navigate to .100.200.100.124. Not so much. To 100.200.100.124 is good. Now our modem is just providing cable, and then our router 100.200.100.50 is good. And now up here, coax gigabit Ethernet is good. Now this is the part that I still need to figure out, is how to get the internet to work. Because I really thought this was how you would do it, right? You set up the port to port, right? So coax goes to gigabit Ethernet and you call it a day. But I'm not quite sure that I have all of the routing working for the internet correctly. However, if we were to set up an intranet server, we'll make one more server here. And in fact, let's put this one in the business office, right? And again, we will replace this, we'll replace this with a gigabit switch or a gigabit switch port. Okay, services, HTTP, oh my God, on. Services, HTTP is on, and FTP is also on. Okay, good. And then we will set up that it has a 10.1.0. Say 15. 255.255.255.0. I realize that we're not capturing flags, we're not doing anything cool like this, but this is the work. This is how the stuff that you use every day actually gets done. And so learning how it's all put together, I think, is well worth our time. And we will connect that to, as I said, I like to put servers at the end. Oh God, so gross. Right up there. Don't use the rails or anything like that. Hey, Al. No RC. Yep. So from my PC, I should now be able to connect to this. Why is the server all the way down here? Let's move you up. You're in the business office. Oh, we need to name it, right? We need to give it a server name. Gunship. That's true. We did put a flag.txt on his espresso machine. I don't know if we have a way to get at it, though. I might have to play with the IoT stuff some more to see if we can make one that's HTTP enabled. That might be fun. Better isolate that espresso machine. Yeah, for sure. Okay, so we got the server and it's up 10.1.0.15. So let's see if I can get to it from here. 10.1.0.15. Hey, look. So in fact, let's go make flag.txt here. Fine, flag.html. And now I just want to know how old this is. How old is this web browser? .1.0.15 flag.html. Yes! Yes! That flag, that HTML tag does not work anymore. Phenomenal. Okay. So we have built out a pretty, functional network here in terms of, we've got wireless going on. We've got some access points. I'm really excited we got that figured out. And now, our next step would be to actually add some security onto this thing. How do we prevent the bad guys from getting in? How do we prevent, these subnets from or how do we create subnets and how do we prevent them from talking to each other? That's kind of the next step. Building this out was a really good component of it. So I think we're going to call it there. Flat network common admin passwords. Yep, that's what we want. And we'll save this network. All right, I think that's going to do it for us today. Thanks. Now, friends, I have to make a quick programming note. I am going to be off for the next week. So no Tuesday stream, no Wednesday stream, no Saturday stream, and then I will be back on Tuesday. Oh, actually, my mistake. I won't be on Tuesday the 26th either. So the next stream is going to be the 27th. Taking some time off. But on Tuesday the 26th, I will be doing a talk at DC615 about Offensive Notion. So if you're in that Discord, you'll know about that, and also you can check them out on Twitter as well. The Nashville area DEF CON chapter. I'll be doing a talk with Husky about Offensive Notion. And because I love you all, here is something else I am going to drop for you today. In the background, I have been working on a platform that is still very much in beta, but if you're here watching it, you get to test it out as well. And this is a platform for building courses about IT and security fundamentals. It's called the Taggart Institute. and it's, as I said, still very much getting built out. You can go check it out at taggertech.edgenex.io, but there is a micro course available for you to take right now, which is an introduction to regular expressions. This is a micro course. You can do it in a night. And so if you want to go enroll, you can go to that link that I just dropped in chat, or you can go to taggart-tech.edgenex.io, and the only course we have right now is the Intro to Regular Expressions. So this is very early days, but I want you to test it out. I want you to see how you like it. What I'm trying to do is come up with a way of building this courseware that's a little bit different than what other folks are doing, and also hopefully have some folks besides myself add content to this platform as well. It is free. At least for now. We may add a nominal subscription fee at some point, but for now it's definitely free for you to test out. So please do so, enroll in the course, and have some fun with it. So that's the deal. I will be back on the 27th, but we're doing that talk at DC 615 on the 26th. Enjoy the course in the meantime. So looks like, does anyone know MSEC, if that would be a good person to raid? That's the only other person I see online right now. But if not, I think we're just going to yeah, we'll give them a raid. We don't know who they are, but let's raid MSEC. So until next time, friends, thank you so much. Thank you for watching. I hope you had a great time and learned something. I know I did. Be good to yourselves, be good to each other, and I'll see you when I get back. Happy hacking, everybody.